Hey everybody! All right. First of all, you'll notice, maybe you'll notice, this lecture has a funny lecture 5.15. I've been trying to get in the habit of having like 5.1, 5.2, 5.3, so that you know it's the third lecture in chapter 5. The problem is I did a 5.1 and I did a 5.2, and then I realized I really want to do one between them, this one. So I made it 5.15. So kind of lecture 1.5 of 5. I don't know. Just trying to put it in the right order. So don't be put off by that. All right. I do kind of want to tie a bow a little bit. So at the very beginning of this chapter, I had a short video talking to you about the brain trying to make sense. And then as you go through the chapter, you ran into things like Gestalt psychology, which really is sort of that same question. You've also run into the issue of top-down processing, and we've talked about that a little bit. So really in this lecture, I want to kind of bring those three together so that you realize they're all kind of related to the same thing. But I also want to show you something at the end of this lecture. Well, I want to make a point about these top-down processes is really what I want to make. And that point, it will be similar to what I made earlier, that really your previous experiences really shape your top-down processes, which then shape how you see the world. I didn't feel like the textbook did the greatest job emphasizing the role that previous experiences played on these things. So that's where I'm going to end. I'm going to make that point strongly. But first of all, just you remember this from the previous section. So just that idea that I want to start with again, that the input part of our brains are amazingly good at extracting order from chaos. Um, that what we see in our mind is not what's out there, but rather a highly processed version of what's out there. Because what's really out there is so chaotic. There's so much information coming at us at any given time. The brain must first kind of select which of all of that information that's coming in it will focus on, and then it really wants to make sense. What is that thing? And so, really when we get to the Gestalt chapter, that is people that were interested in that magic. In a sense, if we start with the word Gestalt again, this is one of those German words where there isn't quite an English equivalent, but the closest thing we have is this notion that the whole is more than the sum of its parts. And so what we mean by that for sensation and perception is, well, the parts are what comes to the eye, right? That's the sensation. That's the actual energy from the external world that comes to the eye. But as it's processed, the brain makes sense of it. So it adds or subtracts, or, you've seen all that kind of stuff. Those are what we're calling the top-down processes. And really, the Gestalt psychologists really wanted to figure out what are the things that the brain is cueing on here? How does it do this filling in? Are there principles at play that determine how these top-down processes work? And so they ended up describing Gestalt laws, which were these sorts of principles. And, you've seen these in the textbook, but I like this. This is just a kind of nice way of kind of grabbing it all in one graphic. So the idea of closure, that even though this is not a full G, it's really three different bits of things, we very easily see it as a full G. The brain just fills in those gaps quite easily and closes this figure, which will be similar to continuation, but we'll talk about that. Proximity, the idea here is just that when things that are close get linked together, simply because they're close, and they end up forming this idea of we see the E coming out there because all those black parts are close to one another and the gray ones are close to one another, so they kind of separate from the black, and it's the actual proximity that makes us group these things. Now, there's a couple of points we're going to make here. We're going to talk about grouping. We're going to talk about figure ground. Let me come back to that. And let me just say for now, this is going on. And let's just go through some of these. Continuation. So in a situation like this, we have this bar actually intersecting the S, right? So you have a full S on the top, you have a full S on the bottom, but again, we've kind of hit this spot where the S doesn't really happen. This notion of good continuation says, yeah, but if we see a line kind of coming in and it would continue right along and fit that, and this one would continue right along and fit that, then what we tend to see is those things continuing. And so yes, of course, we see it behind the bar, and similarly we see the bar continuing right here behind the S. It's kind of like closure, but a little different. This notion that you have, lines above and below, and you just think they would continue on through, even though you don't see it. It's because things are occluded all the time. Well, we'll get to that. So that's a principle. Similarity, so these T's, even though they're kind of far apart, if we make them really similar and distinct from everything else, they seem like they go together somehow. We're going to call that grouping again. And what they're doing here in this middle one is, it's kind of interesting. They don't say it, but there's almost an opposite of closure going on here, which I've never heard the Gestalt people talk about. But in this whole, when you look back and look at this word Gestalt, you have to see this as two separate letters, A and L. So it's kind of like you see a break between them that isn't there, but your brain separates them as though there was sort of a break like this there. So not only can it close a gap, it can kind of add a gap of a sort. Notice the A doesn't even have that crossing part. Doesn't seem to matter to us. We can just kind of fill that in and see it as an A. But what they're pointing at here is, if you now look at the inside of the A, the white part, you can flip this in your mind and see this as a tree, a white tree. And so the point here it's making is really a very primal point you'll get from Gestalt theory, which says the first thing we have to do when we look at the world is figure out what are the objects and what is the background. If you look around your world, you will see objects, but you'll also see walls and floors and etc. And in order to start perceiving something, the first thing you have to do is figure out what its boundaries are. And in fact, one of the critical steps in that is what we call grouping. What goes with that thing and what doesn't. As you look at me, in front here, for example, you kind of know that this part goes with this part. Even though we do not have similarity, right? We have a change in terms of color here. We don't really have continuation. It's not really like, any straight line here or whatnot, but we do have proximity, right? This is very close to this, and that will tend to make it join together. And notice there's all this blue behind me, but you don't connect the blue to me. So I am the figure, it is the ground, and then you can start processing me. And the idea is that these principles would let you know, for example, that maybe, would they? That this is not part of me. This is not stuck on my hand. This is an object I picked up. It's different. And so, with one of these things, if I put them up here, now my hand becomes sort of ground, right? And this is the figure. This is what's important. Even me sort of becomes ground when I do this, because this becomes the necessary thing. So how does the brain do that? How does it figure out figure to ground? Well, the notion is it uses grouping to kind of do that, and it uses grouping to make other assumptions. What parts of things go together. So that's really the Gestalt people are trying to pick apart these principles that the brain uses. So you can read a little bit more about those in the textbook. I really want to jump on the notion of, where did these things come from? How did our brain learn to do these things, and why does it do it? So let me just do some pictures. Let's start with this picture, and let's think about the Gestalt principle of proximity. When we look at this picture, we're going to want to say those two go together, these two go together, and these two in the back go together. Based on proximity alone, things that go together do tend to be closer, right? So if this is a couple, then they will tend to walk closer to each other and keep a distance from other people, especially in this COVID world. And so you've seen this, you've seen that things that go together tend to be closer to one another. And so your brain has seen that all through life, and it begins to assume that now when it's looking at things. So it kind of turns the relationship around. I've noticed things that go together, things that are close together, tend to go together. Um, no, let me say it the other way. I've noticed that things that are together as some sort of unit, like a couple, tend to be close to each other. Okay, and so therefore I will assume that things that are close to each other go together. So it kind of turns it on its head. Here we have similarity. You can guess, even though you maybe know nothing about football, I don't know who any of these three individuals are, but I'm pretty sure this guy and this guy are on one team and this guy's on the opposite team, right? We're literally using similarity to group stuff. And so we see that, we can kind of see it back here, right? You hear issues like, couples who've lived together too long start to dress the same, start to look the same. But there is this notion that we, all through the world, you will see that one way we indicate that things go together is by having common color of some sort. And so that can kind of group somebody together. It can even group, this guy with this guy, even though by proximity they're furthest apart. But they still seem like they go together. So here's the idea again. The brain sees this and it starts to assume it of input. I give you this one. This is an old picture from, I think it's from my yearbook, to be honest, from when I went to high school. I'm in this picture. Can you find me? Can you recognize me in this picture? A kind of fun task. So this is the guys, as we call it. I think everybody's got all the guys have the guys, and this is sort of my guys. There's me up here, still doing the peace sign. I haven't seemed to have lost that one. The point I want to make with this is, if you saw this like it was, if you really thought the reality was exactly what you're seeing there, what are you seeing? Well, first of all, none of us have legs. In fact, some people, all they are is a head. And if you saw that person as just a head, or this person as just a head, wouldn't that be gross and disgusting? I mean, that's what's shown to you, a bunch of heads with a few torsos. Nobody's got legs or a lower body. Again, even when things are occluded, in the real world, we interact with people and we very seldom see all of them all the time. We see parts of them. Other things are in front of their body in some way and occluding their body. And yet the brain knows that those things continue. It knows this person does have a body. It's back there somewhere. We just can't see it. And so it kind of fills it in. It closes it in our minds. And what we see here is 1, 2, 3, 4, 5, 6, 7, 8, 9 whole human beings, even though really we're not seeing the whole human beings at all. And so, if you imagine that for a second, imagine somebody walking, and you can see them all, and then they walk behind a barrier, and then they walk and you can see them all again. In reality, when they're behind the barrier, a bunch of their body disappears. And if your brain saw that, if your brain literally said, oh, there's a whole person, oh my gosh, there's only a half a person, okay, there's a whole person again, just the fact that the world would be constantly changing like that would freak the brain out. But the brain doesn't do that. The brain says, oh, there's a whole person. And even when they go behind, yeah, there's still a whole person. And then they come out, yep, it's a whole person. The brain is not sensitive to all these changes that are constantly happening to the stimulation, because that would overwhelm it. Rather, it just makes these assumptions based on things it has experienced before. Okay, so once more now, I've saved my best demo in my back pocket to really make this point for you, and that's this one. Okay, so, oh, my light on the bowl thing. Shoot, I'm gonna pause. I'll be right back. Alrighty, I'm back. Sorry, I needed a prop for what I'm about to show you. So I had to go downstairs and run and get my prop. I'll use it in just a second. First, I got to mess up your head. So what do we want to start with? It's the same thing in both these, but let's start with this one. What I want you to do is look at this and say, okay, is this one, would you say it's convex or concave? That is, does it bow away from you or does it bow towards you? And so we call it concave if it's away from us, right? And I think most of us would say this is concave. Sort of, it's got a convex edge. So there's an edge that comes out to us, but the middle pops away from us, right? Where's this is reverse? I just ran up and downstairs. Where's this is reverse, right? So are you sure? So, keep your eye on the one that is going away from you. Let's say this one. There we go. And I'm just going to spin this right around here. And anything weird happen? This was the one that was away from you. It's now coming at you. And that one's now going away from you. What? Okay, let's keep an eye on this again. This is the one that goes away from us, right? This is the concave. So let's just spin this around. Oh, what happened? It's now coming out towards us. That one's going away. That's weird. Let's try it over here. This will be easier, right? We've got a whole bunch that are clearly convex and a whole bunch that are clearly concave, right? So it's easy to see, right? So now let's just kind of work this around, and there we go. And oh, hang on, weren't these the ones that were away from us? Now they're coming towards us. Okay, let me put it back. Let me see. It was away from us. Let me see. That's oh, now they're away from us. What the heck? Now they're towards us. What the heck? So what is going on here? Because the stimuli are staying the same. Why does spinning it upside down suddenly make it pop the other way? Okay, so it's all about the lighting and the shading. Okay, and this is something your brain has learned. So now let me do my fun little demo. Get my little flashlight going here. Come on, give me a flashlight. Okay, here's my flashlight. Here's my prop, my bowl. What I want you to realize is if the sun is shining from above, as it usually is in the world, let's look at that. And what do you see? You see that the top of the bowl is pretty bright and the bottom of the bowl is dark. That's when it's popping out towards you, right? This is how things work in the real world, where the sun tends to be above. Well, what if it was convex and the sun is above? What do you see? I can't see what you see, but what you should see is that the bottom part is lit up now and the top part is in shade, right? That's just what happens when a light source comes from above. Let me show you again. So here you see the top part is relatively dark, bottom part relatively light. Oh, sorry. But when we do it the opposite way, top part is relatively light, bottom part is relatively dark. Okay, cool. So what's going on here? The brain just does it backwards, right? The brain has seen this. When things go away from me, then the light tends to be at the bottom of them and the shade at the top. When they come towards me, then the light tends to be at the top and the shade at the bottom. So in these ones right now, the light's at the top and shade's at the bottom. Makes it seem like it's coming out towards us. But when we flip it upside down, now the light is at the bottom and the shade's at the top. And that's what happens when things go away from us. Same thing over here. It's just a little more complicated version of it as well. Same idea. So, wow, huh? I really like this demo because I think it really captures that idea that our brain walked around the world and was attending to the way light hit things and ultimately to the shape of those things. So it interacted with that thing and it learned the shape and it learned how that shape reacts when the light's a certain way. And now it brings those assumptions in. So when it's looking at this, even though it's a two-dimensional thing, it looks three-dimensional because it's brought in that assumption of a light source from above. And when it brings in that assumption of a light source from above, which is what it experiences all the time, we get this dimensionality. But which dimensionality we see depends on how we shade. And if whichever one has the light on the bottom is going to be seen as going away from us, and the ones with the light on the top are going to be seen as coming towards us. So that if we take something and now flip it upside down, so the bright part is now on the bottom instead of the top, then we flip the three-dimensional effect. Okay, this is how the brain makes sense of the world. It takes its experiences, everything you learned as an infant and growing up about how things react, what they look like in the light and what that says about their shape. It learns all this information and then it assumes that all of that is true for everything it will perceive in the future. And when it perceives something, it filters it through all of those assumptions. which are what we're calling our top-down processes, and the Gestalt laws show what some of those are. But again, it's your previous experience, it's your memory system that is helping you perceive what you're perceiving in the world. I hope that made it clear for you. Cool. I'm going to leave it there. I will see you soon in another lecture.